More and more and more probabilities. Here we are with assignment 5. So the first question is just a flurry of questions dealing with a table, and then we get back to some of the questions that are like pulling marbles from a jar or something like that. So we have, again, just more probabilities. One more time, let me bring forth the idea of what probabilities are. So again, we are going to start with the table probabilities, and then we are going to kind of move into some of the more of the wordy kind of problems, which imply and then. Again, I'll kind of hint you in on when we see those. Okay, so again, real quick, the idea behind table probabilities is the probability of A is the number of A's out of the total. The word and, A and B, for instance, that is going to be the intersection of where A intersects with B, and is the intersection out of the total. We have the word or, which is A plus B minus and, or aka the intersection. A plus B minus the intersection. And then we have the word given, so it'll be like A given B. Okay, this is the word given. And in that case, instead of, sorry, this should be out of the total. In this case, this is the only one where the total isn't, in this case, 1,881. In this case, it is whatever comes second, so that is going to be B, and the intersection, the and, is the numerator. So those are your 4 table rules. So let's go ahead and get into it. So staff, there's 53 staff. Students, there's 1,738 students. Okay, here we have the word, oops, sorry, I should have probably did that in a different color. Let's go students again, 1,738. Okay, here we have the word given, so the second piece is going to be the total. So design C is going to be the total, so that's 441. And where that intersects with students, so 441, and where that intersects with students is at 372. So the second piece becomes the total, and the intersection is the numerator. Again, we have the word given. So the second piece is going to be the total. So the teacher is going to be the total. So the teacher is 86. And the intersection with design A is going to be the numerator. So that's 24. Yep. Let's see, what's next? We have and, so just straight up the intersection. So administration with design B, so that intersects with 1. So 1 out of 1,881. Let's see, next we have again the word and, so that's B and administration. So same question, just written backwards, and it doesn't make any difference. So B and administration is still 1. Okay, so here's going to be a little different. So we have 2 pieces. We have teacher or administration. So teacher or administration. So it's both of those. And so where those intersect with design A. So those intersect right there. I can't quite read the number. 24 and 2. So it's teacher or administration, so it's either one of those, and where they intersect with design A, and so that's going to be a grand total of 26. Student and staff, where does student intersect with staff? Where does student intersect with staff? Student intersects with staff? Nowhere. So again, that was the word and. So I'm looking for the intersection and they don't intersect. Student given staff. So staff becomes the total. So staff becomes the total. And that total is 53. Okay, because it's this right here. And where does that enter? So that, sorry. So the denominator is 53 because that's the staff. And the numerator is the intersection with student. Those don't intersect, so that's 0. Not a student, not a student. So the easiest way to kind of identify how many things we're looking at when we're looking at not a student is if there's 1,738 students and there's 1,881 total, that implies that there's 143 that are not students. So 143 are not students. Again, it's out of the grand total. Last but not least, we have this and. So where does student intersect with design C? Where does student intersect with design C? Student with design C is at that 372. Again, this is an and, so it's still out of the grand total. All right, so those are your individual probabilities. Now let's just get the decimals of these. Two. Okay, so here we have an e to the -4, so it's 5.3 something e -4. So that means we move it 4 decimal places, making it smaller. So that'd be 0.0005. Next one will be obviously the same answer. All right, so those are table problems. Again, they revolve around these 4 ideas right here, which are presented here on the left. Okay, now the next is going to be a lot of and then problems. Again, the key idea is when you see the word and, you're in essence going to be multiplying something most likely. You're going to be multiplying something most likely. And it's like, you know, this, and then multiply that. Okay, and it can come in a bunch of different ways. Ultimately, what you're doing is you're multiplying A with B, whether it's A with B straight up, A with B given A, or B with A given B. All right, so let's see the lay of the land here. A student council is made up of 4 women. So 4 women, 6 men. So that makes 10 total. A member of the council is okay. What is the probability? Okay, one of the women is the president. So I'll just say one of these is a president. Write that on the side. What is the probability that a woman is selected? That'd be 4 out of 10. 4. What is the probability that a man is selected? 6 out of 10. What is the probability that the president is selected? 1 out of 10. Pretty easy. Here's our jar. So we have 6 red, 8 green, 3 blue. Okay, the first one is with replacement. The second one is the same problem, but with not replacement. And so this is going to be this and then that. So it's going to be red and then a green. Red and then a green. So you multiply the 2 different things. All right, so the first one is with replacement. So the first one is red and then a green. Okay, this one is without replacement. Again, what would happen is this. If I select a red first, that would leave 5 red and 16 total. Okay, when I select that. However, when I select that, okay, this occurs, but when I replace it, it goes back to 6 and 17. Okay, so all the numbers go back. So in the second problem, I first select a red. So again, that's 6 out of 17, which sets up a scenario that looks something like this. But now I don't put that ball back. So the numbers aren't going to revert back to what they once were, but they're going to stay like it is here. So now when I select that green ball, the green is not 8 out of 17, but rather 8 out of 16. Okay, so Dean at Hillsdale College found that 12% of female students are majoring in computer science. So that would be the probability of female given computer science. Or excuse me, no, I'm sorry. Of the female students. So given that they're female, of the female students. So of the female students, who's in computer science? So is computer science given that they're female, not the other way around? He's not looking 12% of the, not 12% of the computer science people are female. He's finding of the females, 12% are in computer science. If 64% of the students are female, so the probability of just generally being a female is 64%. What is the probability that a student choosing at random will be a female majoring in computer science? So a female and computer science. So the probability of being a female and computer science, this would be the setup of probability of F times the probability of C given F. And so that is going to be 0.64 times 0.12. Let me bring in my deck of cards. Again, on the test, I will provide my little table. It's just I didn't attach it to my assignments. Haven't. So here's my deck of cards. This will kind of help me. So now I can kind of turn them into a table problem as opposed to trying to figure this out just straight up using my brain. Okay, the word or is A plus B minus and, or AKA the intersection. A plus B minus and out of the total. So a heart, okay, a heart, there's 13. Or a spade, there's 13, minus the intersection, which is 0, out of the total, 52. So we have a jack, 4, or a red card, which there's 26, minus the intersections, which are 2. Next, last one is law of large numbers. Don't overthink it. Just find the probability of what they want. So a coin is 1 half. Don't overthink that last one.